Hi champs, welcome back and let us continue our discussion on the classification of reaction, and in this video we will discuss on the double displacement reaction because we discussed about the displacement reaction in the previous video, double displacement. Now double displacement reaction is very simple. It's very simple. You have the compound AB and you have the compound CD. What happens is when they exchange the ions, it gives AD and BC. This is what is all about, AD and CB to be precise. So let's see an example and you'll understand it very easily. So here we have sodium sulfate. Let's assume that sodium sulfate is A and B. Sulfate group is B, sodium is A. Barium chloride. Let barium be C and chloride be D. What it gives? It gives NaCl. What is NaCl? NaCl is nothing but sodium chloride, and that is Ad. And then you have barium sulfate, that is Cb. This is what I meant. So there you see, okay? You see there, that is the reaction. That clearly it gives you the picture about what double displacement is all about. Okay, so in the above reaction, the reactants exchange the ions and results in the formation of barium sulfate, which is solid and insoluble in water. This is called the precipitation reaction. Now, just like exothermic, endothermic, in double displacement, we have a new classification called the precipitation reaction. So let's see what it is. The definition of precipitation reaction: a chemical reaction occurring in an aqueous solution where two ionic bonds combine, resulting in the formation of an insoluble salt. So when an insoluble salt is formed in the reaction which happens in an aqueous solution, then that is what precipitation is all about. So that salt will sediment, it will go to the bottom, it will sediment. It is insoluble, it will not exist in aqueous format. It will be in crystalline solid format and insoluble in water. That is what double displacement is all about, and let us discuss about oxidation and reduction reaction. So what is oxidation and what is reduction? Now take a china dish, put some copper filling and heat it. When you heat it, the heated copper reacts with the oxygen in the atmosphere and it forms a coat of copper oxide, which is black in color. Right, now keep it keep the heating going on, but then all you need to do is pass hydrogen gas over this. The hydrogen reacts with the oxygen in copper oxide and it forms H2O and it evaporates. What you get back is copper. What you get back is copper. Get it right? So that brown lustrous metal you'll get back by passing hydrogen over copper oxide. You get it right? So this is what it is, but let's understand what oxidation and reaction and reduction is all about. So see here, copper reacts with oxygen to give copper oxide. Copper gains oxygen, CuO, hence this is oxidation, right? And that CuO, when hydrogen is passed over that CuO, we get Cu and H2O. Now copper loses oxygen. So two types of reactions: copper gaining oxygen, copper losing oxygen. Now let's go ahead and try to categorize them. In the above mentioned reaction, copper oxide loses oxygen, hence it is called a reduction reaction. The hydrogen gained the oxygen, hence it is called the oxidation for hydrogen. As far as copper is concerned on the above reaction, it is reduced. It's a reduction because it loses oxygen. But with respect to hydrogen, it gains the oxygen, so it is an oxidation reaction. So what happens is, generally, oxidation and reaction go hand in hand. So that's the reason it's called the reduction, oxidation, redox reactions. So here again we see ZnO plus C gives Zn plus CO, MnO2 plus HCl gives MnCl2 plus H2O plus Cl2. So in summary, if a substance gains oxygen or loses hydrogen during a reaction, it is said to be oxidized. Gaining oxygen and losing hydrogen is oxidation. If a substance loses, if a substance loses oxygen or gains hydrogen during a reaction, then it is called a reduction reaction, or it is said to be reduced. So let's see the effects of oxidation. Okay, any metal, say for example iron or zinc or anything like that, when it is exposed to air, it will react with the oxygen in the air and it will form a coating of oxide. Now this oxide again, it forms as a coating with a different color. Usually when we see iron articles made of iron for the first time, when it is removed from the cover, it's very shiny. It has a luster. But after exposure to air for a few days or weeks, a black coat forms. Same with silver. A black coat forms. In iron, a brown coat forms. I'm sorry, it's not a black coat. A brown coat forms. In silver, a black coat forms. So all this is, collectively called as corrosion. And the corrosion of iron is usually called as, it's called rusting. Okay, this permanently damages the iron articles. So we need to protect iron articles from getting rusted. Not only iron articles, any article that is made of any metal which can react with the atmospheric oxygen, it needs to be painted and protected. Then you have rancidity. Okay, now that's very interesting. See, you have the deep fried potato chips, right? So when they are deep fried, it contains some oil and some fat. When that is exposed to air, again oil and fat can react with air. So when it reacts with air, what happens is the taste and the smell changes. You cannot consume it anymore. You cannot eat it anymore. So it actually in a way spoils the food. That's what we call, the food is spoiled, spoiling. So that is what is called as rancidity. Rancidity is nothing but the fat and the oil in the fried food items. When they get oxidized by exposure to air, then its smell changes, its taste also changes, and you cannot consume it anymore. That is what is called as rancidity. So keeping the food in airtight containers, or when you pack it, you have to pack it with filled with nitrogen. Nitrogen doesn't react, it prevents oxidation, so the food will remain fresh for a longer period of time. Now that is what it's all about. So you fill it with nitrogen and the food remains good for a longer period of time. So it prevents rancidity. So those are some of the practical observations with respect to oxidation that we find in our day-to-day life. Okay, thank you. We'll meet in the next video.